Students, this is our tutorial. I am logic videos on analytic geometry, and I have started to discuss analytic geometry dimensional, uh, parabola, ellipse, and hyperbola. Parabola I already discussed. Now today we will discuss about ellipse, how the equation can be obtained, and what are the other properties of ellipse. Let's start. I have shown that eccentricity, if eccentricity E less than 1, then we can found the geometrical um, figure is ellipse. So, making the eccentricity less than 1 will obtain the equation of a ellipse. Let's see. Let this is the x-axis and y-axis. Now, ellipses are oval in diagram, so it must have a directrix. I am taking the directrix. This is the equation of the directrix. Now, the fixed point I am taking here is the fixed point, and if we draw, then we will get in this way. Through this directrix and through fixed point, we will get in this way the ellipse. This is the half ellipse actually. This is its coordinate we are taking x, y. This is the SP distance from the distance from the directrix and the general point on the ellipse, and this SM is the distance from the fixed point and the variable point. So this is the origin. We are taking that the ellipse intersects the x-axis at a0 point. The x-axis, this is y-axis. So here we are taking the point, and the coordinate of the point is a0. Now, to make the other half, we'll take another directrix which is perpendicular on x-axis parallel to the first directrix. Means this directrix is parallel to the same directrix this is, and if we put a mirror here, then we will get the image in this way. Image will get in this way. Found the full ellipse. Here, in the same way, we will get the fixed point. I am giving m prime. This will be minus coordinate is not given. This will be minus a0. This will be minus a0. Minus a0. And there we will get the fixed variable point. This is given s prime. All the image points are given through prime. Here we will get p prime. Here we get sm, s prime, m prime. So since we are obtaining the equation of the ellipse, we wish to obtain the equation of the ellipse, then we know that what is the ratio between SP by PM. SP by PM must be less than 1. E must be 1. So this is E we are taking which is less than 1. So we will put, we does not put less than 1. We just put S by PM is equal to eccentricity which is less than 1. Now if this point is gravel point which goes through the full ellipse, when it comes at this point we will get SM by SP in this way, SM by SP. So here this O to this point I am taking this point A, capital A. So OA is A, and when the point, variable point is to know this is the focus this point, fixed point is the focus of the ellipse. The two focuses here, M and M prime, and A is the axis of the ellipse. So we'll later discuss about the axis. Now we wish to deduce the coordinate of the fixed point focus. So we'll use SM and PM. Here will be this is the distance OA is equal to EA. So if SM S point is here, then SM by PM this will be the mean OM. Actually so this is given X. So then it is given X. The point when comes here, this will be this will be S really is P by PM equal to E. Now SP can be evaluated through this, but the focus coordinate and the directrix equation is necessary to obtain to get the equation. So now here this is actually A and this is minus A. So we'll get this way. Here we can do this from this point A to A prime. This is 2A. A to A prime is 2A. A to A prime 2A. Now when the S variable point comes at A prime, then we will get SM S then SM will be this distance M A prime, right? M A prime and M A prime by S X. This is taken. Take B. Then this point B. This is the point B. Then M A prime by M A prime B. A prime B. Here is not P. Sorry. SP by SM. This will be SP. Actually SM. The distance between the fixed point and variable point by SP. This is eccentricity. So here we will get M A prime by A prime B equal to E. M A prime can be reduced by A prime B. Now also M A by AX, M A by AX also will be E. M A by AX will be E. So both are equal to AB, sorry, MA by AB equal to E. So both are equal to the eccentricity. Since the L is defined in this way, MA by AB on the point the S point is at the point A, then MA by AB will be E, and when the variable point comes at the A prime, we will get MA prime by A prime B equal to E. Through this relation, we get uh, we will try to find out OM and OB. So we are writing in uh, another side. Look this. So we are getting A AB M A prime by A prime B equal to the eccentricity. Written AB M prime. M prime will be OM. You can look the figure. Just reducing the time. You can look the figure. OM plus O A prime. And A prime B will be OB OA prime. Now from this we will get this can be written MAD can be written OA minus OM and AB can be written OB minus OA. This is this OM we have to reduce OM. OA prime is equal to minus A. We have to again reduce and OA prime will be minus A equal to E. Now again OA is positive A minus OA and OB we have to reduce OB minus A equal to OA minus A by OB minus A equal to E. Now from this relation, from this relation we will get a relation between OM and OB. We will take first and third, then second, second time we will take second and third. So first we will take, then we will get first and third. If we will get take A minus VM is equal to OB minus OBE minus E. From the second and third we will get OM minus OA, OM minus A is equal to OBE problem is occurring. Take the figure. These are the directories to directories. Now the is first the M employee P S is prime P. Here A0 minus A0. Now we used to know the distance OA and O E. Here I am giving A1. OA and OM to unit. So for this suppose we take that we know that when this word comes here, this is here. So the relation becomes by B equal to MC by MB by BA, MC by CA equal to E, eccentricity. Now, MB can be written, MB is, you can find that it is A minus wave, A minus wave, and BA is equal to wave minus OB, which is A. So wave minus A, minus A. What will be the MC? MC will be wave plus OC. A find the answer. This will not be the minus, this will be the plus actually. That's why I think find the answer. So this will be wave, because this is a distance. Here we can write minus A. This will be plus A. Plus A plus wave. And CA will be here wave plus wave OC. This is A. So wave plus A. Now we can easily find out the answer is equal to E. So from the two from this relation you can find out the relation. I'm erasing this figure. I already drawn. Figure is same. The calculator was wrong at one part. That's why I couldn't find. Now this is corrected. Now look how can it be reduced. So from the first and third we'll get A minus wave equal to wave equal to wave E minus E. And from the second and third, the second and third we will get wave plus E equal to wave into E plus this E, and then E. Now since we want to know wave separately and OA also separately, so we'll subtract the both of them, then OA are cancels. So if we subtract, then minus A cancels, plus A minus A cancels, we'll get minus 2OM minus 2OM. Here this is cancels after minus taking subtracting, and we will get minus 2A. This is our required value. Some mistake in mathematics cannot make you able to bring the required result. That's happened, and that's sorry for this. This actually OEM is equal to after cancelling two both sides we will get E. And how we'll calculate now O A will also the required value. So we'll now add first and second. Then OM cancels. We'll get 2A in the left side, and on the right side we are looking at A cancels. We add first and second equation, and we will get on the right side 2A. Then if 2 cancels, then OA is equal to OA is equal to A bar E. Now these are the required required to evaluate the equation of the ellipse. Now we know that if we again draw the figure, now again I am drawing figure to make you understood. And there was the ellipse. This is the directrix on the both side. So we'll get O here, and this is the focus. So OM means here we'll get the O A0 coordinate was this point A0, and OM here M. So the focus coordinate will be AE0. Focus coordinate is AE0, and the equation of the directrix what will be OA. So X equal to A by E is equal to the directrix equation. So there are two directrices, so we will put plus minus A by E, plus minus A by E. Two directrix equation, plus minus A by E, and two focus points. The focus points focus coordinates are plus minus A by E. This will be minus AE and 0. Now we'll take the equation to evaluate the equation of the we'll use this points coordinate to evaluate the equation of the ellipse. Now we already know that the ratio between the distance of this and this will be E. So and here I am taking even AM. This is AS, and this is P. So now M by SP is equal to E. Now erasing above results. Here SM will be S is the XY point. So here we will get from the SM, for SM we will get root over X minus EE whole square plus Y whole square. In this side E will come E into SP. SP will be can be used in this way. This is the equation. I'm taking positive. The directrix is on the positive direction. So this will be X minus A by E, and below root over 1, this will be 1. getting 1. Now if we square on both sides, then we will get x square minus 2x e plus a square plus y square. On the right side, we will get e square x square minus, this will be a minus b whole square. So 2x e will be multiplied. So 2x a plus again e square multiplied. Sorry, e square will be multiplied. So there will be e and here will get e square just e square. By using the figure, you get the equation. We are reducing the equation of the ellipse. Here, this will cancel. Both are cancelled. Now, if we arrange this, and there are 2x square, we will take e is less than 1. So, we will take 1 minus e square common plus to multiply x square plus y square and if this is being on the right side, then we will get a square 1 minus a square. If we divide by a square into 1 minus a square, the whole equation, then we will find x square by a square plus y square by a square minus a square is equal to 1. This is our required equation. If the if will find out this equation now. Now we again erase and figure draw the figure again. Introduce these points. This is our required equation, but this is further evaluated in a good way. So small figure. Now here this is called major axis of the ellipse. So this will be 2a. So this is the major axis length is 2a, and this is called the minor axis. So if we'll take, I have already taken this is a0. So major axis length is 2a, and minor axis if we'll take 0b, the length of the minor axis is what is 2b. So we want to represent the equation in terms of b, because major axis and minor axis are given by a0 and 0b. So we want to represent this equation through taking these points a and b. So how can it be done? Now we will take find the point, travel point, S point will come here, then the distance will be this O. I am taking this point is now C, again C, and this point is the length is D. So then one travel point will come at the point C, then OC by OD will be OC by OD will be the eccentricity. Sorry, CD. CD will be the eccentricity. So OC is given B. OC is given B, and CD our A by E. The distance from the point, and this is I have already taken. This must be X equal to A by E. So OC, sorry, OC not MC. Here the focus point. From MC by CD. MC by CD. So MC what will be? MC will be MC will be the distance from the focus to the point here. So it will be root over A is first point is AE 0. So A square plus uh, B square, right? AE 0. So A square, the distance is A square B square, and the CD will be A by E. So it will be equal to E. Now from this we will get that E cancels, E will up at this point, and E will cancel. We will get A square E square plus B square equal to A square. From this we can look that B square will be A square minus A square E square. From this, if we take A square common, we will get this term A square 1 minus E square. So we can replace this by B square. I think you can understand this. Just calculate it simply. B square is equal to A square minus E square, E square, E square take common, then A square in first bracket to 1 minus E square. This is the term here written. So this must be equal to the B square. So this is our required equation of ellipse, and this is x square by A square plus Y square by B square equal to 1. And B is related with A is with this relation. B is related with A square with this relation. These are the important relations. I think you like the video. Uh, so if you like, then subscribe. subscribe this channel and share with your friends, and and continue enjoy this channel. Thank you very much.